So now we are starting with part 2, fundamental particles. In that we are going to learn properties of electron. So now we will just discuss and I will tell you some few points to remember. So the first point, electron was discovered by Sir J.J. Thomson. You all know that. The charges on the electron is 1.6 into 10 raised to minus 19 coulomb Milken. So now the third point is the molar mass of electron is 5.48 into 10 raised to minus 4 gram per mole. So in the fourth point, the mass of electron in motion is expressed as m is mass of electron in motion, and upper m is the raised mass, and 1 minus v raised to 2. V raised to 2 is velocity of the electron and c raised to 2 is velocity of light. It is in half. Okay. So now we will discuss some 3 points. Okay. In 1897, J.J. Thomas determined the E raised to m value, like charge into mass, of the electron by studying the deflection of cathode rays in electric and magnetic field. The values of E raised to m has been found to be minus 1.7588 into 10 raised to 8 coulomb. The first precise measurement of the charge on the electron was made by Robert A. Millikan in 1909. By oil drop experiment, its value was found to be minus 1.6022 into 10 raised to minus 19 coulomb. Now the 7th point, the mass of electron can be calculated from the value of Em, and the value of which is 9.1096 into 10 raised to minus 31 kg. Okay. So this was the properties of electron. I will tell you some points where you have to remember. You have to remember the name of J.J. Thomas, who calculate the charges of electron, Millikan, molar mass of electron, and you have to remember this experiment. Okay, and you have to remember some these points, and the value was found by Robert A. Millikan. Okay. Now we will start with cathode rays. The electron was discovered as a result of the studies of the passage of electricity through gases at extremely low pressure, known as discharge tube experiment. So the cathode rays is also known as discharge tube experiment. When a high voltage of the order of 10,000 volts or more was spread across the electrodes, some sort of invisible rays move from negative electrode to the positive electrode. These rays are called as cathode rays. Can you see your cathode rays? These are cathode rays. And here is 10,000 volts, means it is almost high voltage. And this is formed as cathode rays. Now we will just go through properties. You just have to listen it. Path of traveling is straight from the cathode with a very high velocity as it produces shadows of an object placed in its path. Cathode rays produce mechanical effect. If a small pedal wheel is placed between the electrode, it rotates. This indicates the cathode rays consist of material part rays possess heating effect. When electric and magnetic field are applied to the cathode rays in the discharge tube, the rays are deflected, thus establish that they consist of charged particles. Cathode rays produce X-ray when they strike against hard metal like tungsten, copper, etc. When the cathode rays are allowed to strike a thin metal foil, it gets heat up, thus the cathode rays possess heating effect. They produce a green glow when strike the glass wall. Beyond the anode, light is emitted when they strike the zinc sulfide screen. They produce a green glow when they strike the glass wall. Beyond the anode, light is emitted when they strike the zinc sulfide screen. Cathode rays penetrate through thin sheet of aluminum and other metals. They affect the photographic plates. The ratio of charge to mass, etc. Charge is into mass is same for all the cathode rays irrespective of the gas used in the tube. Okay, so this is the cathode rays. It also explained in NCRT. So I have explained that only in simple words. Okay. Now we will start with second topic, properties of proton. Proton was discovered by Goldstein. Proton carries a charge of plus 1.602 into 10 raised to minus 19 coulomb. Example, 1 unit positive charge. Mass of proton is 1.672 into 10 raised to minus 27 kg or 1.0072 nm. A proton is defined as a subatomic particle which have a mass nearly 1 nm and a charge of plus 1 unit. So now we are starting with positive rays discovery of proton. The existence of positive charge particle is an atom was shown by E. Goldstein in 1886. He repeated the same discharge tube experiment by using perforated cathodes. Can you see in a diagram perforated cathodes? It was observed that when a high potential difference was applied between the electrode, not only cathode rays were produced, but also a new type of rays were produced simultaneously from anode moving towards cathode and passed through the holes or canal of the cathode. This termed as canal ray or cathode ray. Characteristics of cathode rays are as follows. These rays travel in straight line and cast shadow of the object placed in the path. The anode rays are deflected by the magnetic and electric field like cathode rays, but direction is different. But mean these rays are positively charged. These rays have kinetic energy and produce heating effect also. The E/M ratio for these rays is smaller than that of electron. Unlike cathode rays, their EM value is dependent upon the nature of the gas taken in the tube. These rays produce flashes of light on zinc sulfide screen. These rays can pass through thin metal foils. They are capable to produce ionization in gases. They can produce physical and chemical changes. Now we will start with properties of neutrons. This was discovered 20 years after the structure of atom was elucidated by Rutherford. It has been found that for all atoms except hydrogen, atomic mass is more than atomic number. Thus, Rutherford 1920 suggested that in an atom there must be present at least a third type of fundamental particles. It should be electrically neutral and possess mass nearly equal to that of proton. He proposed its name as neutron. Chadwick 1932 bombarded barium with steam of a particle and absorbed electrically and magnetically neutral radiation. There was a neutral particle which was called neutron. Nuclear reaction. The nuclear reaction. It is very important. Please note it in your NCRT also, because sometimes in NEET exam or in JEE exam also, they can ask you reaction. They will give a suitable labels like what is A, what is B, and what is C, and why they are uses. A neutron is a subatomic particle which has mass 1.675 into 10 raised to minus 24 gram, approximately 1 nm, or nearly equal to the mass of proton on hydrogen atom and carrying no electrically charge. So the question is asked in JEE and NEET also, that what is the mass of neutron? You have to remember that mass of neutron is 1.675 into 10 raised to minus 27 kg. It's really important. Please remember these two things because they mainly ask in NTA, and I'm also going to give you the question on this also.